sample size is needed, assuming we use a prior estimate of music teachers of 74% or 0.74, something like that, then we would use that. But I wouldn't do it based on the sample I just got. I wouldn't.
Thank you.
You're wrong. Anyway. All right, so the next one is, so the food chemist analyzed the calorie content for a popular type of chocolate cookie. Following are the numbers of calories in a sample of 8 cookies. So they give us the different calorie counts. Pretty simple so far. And then you get these printouts. Use the following information generated by Minitab. So you want to know what these printouts are and how to use them. They're labeled here, normal probability plot of cookie calories and box plot of cookie calories. So one's a normal probability plot and one's a box plot. And then you also have this little printout here, which hopefully this is now clear. This is the 98% confidence interval for the population mean. And it's saying it's between 112.38 and 118.37. Those are calories. All right, so the first question says, find a point estimate for the mean calories in a popular brand of chocolate cookie. Label your statistic with the correct symbol. So I want the point estimate for the mean. So what is that symbol? X bar. X bar, right. X bar is the point estimate for the mean. P hat is the point estimate for proportion. All right, so they didn't give me X bar. Yeah, it's just the sample average. I mean, you can put this in your list, L1, and then run the 1 bar stats on it, which might be good, but I think if you really want to do a little bit more by hand, you would need S, but I don't think, no, we didn't do that on here, so I'm not going to worry about it. Yeah, so we really don't need it. So you can do that. And really, I don't know. I'm not going to get it. You know, the constant interval, all they do is they take the point estimate and add a margin of error and subtract the margin of error. So if you take the average of these two numbers, you should land dead in between them, which will be the point estimate. But anyways, the better thing to do is just add up these numbers and divide by 8. But I did test this one, and this one does work. If you take the average of these two numbers, you do the exact same thing. So let me go back over here so I can flip back and forth. So 113 plus 114, 115, 20, 119, 116, 923 divided by 8, 115.375. And if I take the average of these two numbers, 112.38 plus 118.37, yeah, and then divided by 2, I also get the 115.375. So that should always work.
Okay, so just not add all those numbers.
Yes, I mean, if you have the constant interval, or they've already used the point estimate to construct the constant interval, so if you kind of understand that the constant interval, the point estimate is dead in between these two values, then you just have to average those two values, it'll get yourself right in the middle. But either way is fine. So are we okay with how we got the average X bar by just adding up the numbers and dividing by 8? So 115.375, I believe. And because this is an average, I want to label my units, and this is what? Calories. Thank you. Yes, calories. So that's the average calories in the 8 cookies in my sample. All right. So that's the point estimate. Now I need to check some requirements. So these are on page 484. All right, so here's another one. X bar is from a random sample. We'll have to assume that again. I've talked to a few instructors and they kind of talk about all these assumptions are kind of not really necessary anyway. So a lot of times you just assume the random sample, but